Hello and a very warm welcome to the Hibernate and Java Persistence training course. I'm Richard Chesterwood. I'm a trainer with the Virtual Pair Programmers and I'm also a working Java programmer. I've been using Hibernate since about 2005 and I'm going to be taking you through this course. We'll be starting from the most basic Hibernate topics and we'll be working our way through to the most advanced Hibernate topics. I've tried to make this course suitable for anyone wanting to get started with Hibernate or for those with some Hibernate knowledge who want to understand the sometimes dark corners of the tool. All you need is some previous Java experience. I'll assume that you're okay with the basic Java syntax and that you can write classes and create objects. If we reach any Java that's beyond the basics, I'll always be careful to explain the background behind any new concepts. I'm going to be working through the course in the Eclipse development environment, but really I won't be using it for anything more than basic text editing. So don't worry too much about IDEs. Now, Hibernate is a database tool, but you don't need any particular database knowledge for the course. I'll be explaining everything along the way. Some previous knowledge of SQL would be useful, but in the next chapter, I will do a quick introduction to SQL if you're new to it. In this opening chapter, we'll take a high-level view of Hibernate. I'll start by introducing Hibernate. I'll give you a rundown on what it is and what it aims to do. We'll also do a preview of the course. I'll give you a rundown of the chapters that we're going to be following. It's a big course, around 23 hours, but some of the chapters are optional, and some of them you can skip if you already know basic Hibernate. If you're brand new to Hibernate and looking to get started with this course, then you don't need to do all of the chapters immediately. You can just build on the concepts as you go along. Just a quick word now on how the course is structured. Really, the entire course is one big practical session. Almost from the start, well, at least the next chapter, we'll be working in our development environment together. We'll have almost no code to start with, and we're going to build running Hibernate code together. Now, of course, it's entirely up to you how you do this course, but my intention is that while you're watching the videos, you have your own IDE open in another window, if you can, in another monitor, and you'll be working in your IDE alongside me. That's why we call our company Virtual Pair Programmers. So you're not going to be listening to a trainer just talking endlessly about Hibernate. You're going to be doing Hibernate from the start. Now, occasionally we might hit a new concept or we might need a code block that's a bit hard, so I'll sometimes switch to a caption like this one, which will give us a chance just to have a chat about the concepts. But we'll soon be back into the code, and I promise you that this isn't some kind of massive PowerPoint presentation. Alright then, the first thing to do is to introduce you to Hibernate for the first time. Hibernate is an open source tool, its website is here, and therefore it's free to use. If you're interested, it uses the Lesser GNU public license, which means that you can use it on commercial software projects, kind of without too many restrictions. And indeed, it is used by many software projects throughout the world. It's almost a standard way of accessing databases in Java. I'll talk about the almost later in the course. So what is Hibernate then? If I have to give you that in a single sentence, I'm going to say that Hibernate is a tool which will generate SQL for you. It's actually quite a lot more than that. Why do we want to use it? Not really because SQL is hard to write, but because SQL can be quite hard to fit into many projects. Let me explain why. Well, I think there are actually two reasons. The first reason is an easy one, and that is that JDBC is a nightmare. Well, just in case you haven't seen JDBC before, that's the library that you can use in standard Java to issue SQL statements. Let's say that you want to insert a piece of data into the database. Then you need a whole block of code to do that, and it looks something like this. And it's very nearly a screen full, and it is really hard work. The exception handling, in particular, to close connections if something goes wrong, is really hard. By the way, Java 7 has improved on that a little bit, but Java 7 is relatively new. And even so, without the exceptions, JDBC is still hard work. JDBC doesn't really understand the concepts of object orientation. I can't take a regular Java object and pass it to JDBC to put into a database. No, I've got to break apart the object, take out all of the primitive data, and construct an SQL statement. There are other libraries available to make JDBC easier to work with. Spring JDBC, for example, is one library. We've covered that on our Spring Fundamentals course. And there's another one called MyBatis, which is excellent. Unfortunately, it doesn't seem to get used that often, but it's a great framework. And the thing about MyBatis and Spring JDBC is that we still write the SQL statements, and these frameworks give us really quite clean code. But if you decide to use Hibernate, then Hibernate not only makes issuing a database command easier, Hibernate will even generate the routine SQL for you. Later on in the course, we'll see that inserting a row can become a single line of code like this, and making a query on the database can look something like this. Now, I'm not saying there's anything wrong with writing SQL. In fact, even using Hibernate, you probably are still going to want to write SQL for your very complex queries. But for the routine queries, Hibernate can cut out a lot of really routine, repetitive coding. So that's the easy reason how Hibernate can help you. But I think the real reason that Hibernate is useful to so many projects is that we have a real tension in the software development world. On the one hand, many projects like object orientation, but on the other hand, many projects also want to be able to store their data in a relational database, as well as writing their code in an object-oriented way. There's nothing wrong with storing data in relational databases, but the problem is the relational model is a different model to the object-oriented model. The point is they are different ways of thinking, different ways of working, and trying to maintain both ways of working at the same time on a project can cause some real tension. This tension is a well-known concept in the software development world. It's called the object relational impedance mismatch. And I've just done a quick Google search here. You can see I'm getting a lot of hits. I think it's a slightly jargony term, but the starting point, if you want to study this in a bit more detail, is to check out the Wikipedia page on this mismatch. Feel free to study this if you have the time to do so. But over the next few minutes, I'm going to summarize what the big mismatches are between objects and relational. Don't get me wrong, most of the mismatches you can work around. But I guess what I'm trying to say is, the workarounds end up getting in the way of you being productive and getting on with delivering your business requirements. The most obvious aspect of this mismatch is that if you're developing on a database, once you create some data, it's persistent. And by persistent, I mean it's going to live forever. Well, not really forever, but it's going to live at least until we delete it. But in Java, when you create some data, for us, that's using the new keyword. Once we reach the end of the main method, the virtual machine shuts down and all the objects in memory are destroyed. And of course, we have to work quite hard to make our objects persistent. We'd either have to write some code to save the data to a disk file, or of course we could use something like JDBC. But that's not the only tension. For example, a class, probably the most important concept that we have to work with in object orientation, is really different to a table, which of course is the most important concept on a relational database. If we just think about the data for a moment, the granularity of data that we want to store in a class and a table may well be different. When designing an object model and a relational model, your concerns are different. On the object model, you're more concerned with building classes that have tightly related functionality, and you try to make sure that the classes don't get too big and that you don't have unrelated data and methods in the class. Whereas with a relational table, one of your prime concerns is performance. And you're also going to be very careful to avoid repeating data. So data integrity is a key concern here. Whereas we would think nothing of taking a class and breaking it down into several smaller classes, in Chapter 16 on this course, when we look at embedding objects, we'll see that often you want to have the data for more than one class stored in a single database table. And sometimes you want the opposite. A single class with the data stored in several different tables. And another problem is with data types. You know, for example, that the Java string data type can hold as many characters as you like. Well, okay, there's a practical limit on strings because memory isn't infinite, and many of the methods in the string class are based on ints. So I guess you can have around 2 billion characters in a Java string, but you don't need to specify how big the string is going to be up front. Whereas on a database, you're defining the way the data is going to be physically stored on a spinning hard disk. So you have to specify the size of your data. Again, it's not a killer difference, but having to convert types as we save and load data is another pain that gets in the way of doing business code. And then there's inheritance. Of course, inheritance is a central concept in object orientation, but there's no analogy to that in a relational database. How am I going to map that to a database? It can be done, but it's not natural. And it's going to mean we're going to have to write some code to transform our objects into data suitable for a table. There are plenty more mismatches. For example, relationships are different in object orientation and in relational databases, but I won't go on about them right now. As we go through this course, we'll keep seeing these mismatches and we'll see how Hibernate can help. So, all of these mismatches, or tensions as I called them, get in the way of us writing great code for our projects. The solution that the industry has come up with has a general term, which is called ORM. It stands for Object Relational Mapping. And the general idea behind ORM is that we write our code in regular, natural object orientation, where we've got normal classes with data and methods, whereas here on the right-hand side we will build a normal database schema with all the features that you'd expect, constraints, a good schema, and so on. And this layer of software in the middle, the ORM, manages the gap between the two. So here on the left I might call some methods which changes some data, and the ORM will somehow pick up those changes and issue the necessary updates to the database, which will keep the data in the database in sync with the data in our objects. That's the aim of an ORM. And in an ideal world, the ORM would be completely in the background and we would write Java code without having to make any compromises at all. So in an ideal world, we'd have perfect object orientation with a perfect database schema and no pain. Well, unfortunately, we don't live in an ideal world, and at least right now, at the time of recording, there doesn't exist a single ORM that achieves that perfection. The best we can hope for is reasonable OO, where we have to make a few compromises, where we have a reasonable schema, where again we make a few compromises, and we get a little bit of pain. Hibernate then is one example of an ORM. There are actually quite a few more in the Java world, and we'll be seeing some of them on this course, but I'll focus on Hibernate right now because it's probably the most widely used in Java. Just a little bit about Hibernate's history. It was started back in 2001, an awful long time ago now, by a software developer called Gavin King. And rather than being some kind of committee member, at the time Gavin was a working programmer and he was frustrated by the ORMs that existed at the time. Now, Hibernate only really became popular in the Java world in around 2004, 2005. And it's really hard for me to get across on this course just how dramatic the impact of Hibernate was. Before Hibernate came along, it felt like most people believed that ORMs would never work. And then once Hibernate became popular, people realized that, yeah, ORMs could work. They're not perfect, but they can deliver great working software. Gavin's quite a forceful character, as you'll find if you ever cross swords with him on any kind of forum. But his character really persuaded a lot of Java projects that ORM was something worth trying. So, well over 10 years on from the inception of Hibernate, ORM is thriving in Java. The current version is version 4, but really there haven't been any massive differences between Hibernate 2, 3 and 4. Obviously there are new features added all the time, but the fundamental model of working hasn't really changed. So it's quite a solid platform to work on. Gavin, if you're interested, now works for the company called JBoss. So JBoss have a very big say in the development of Hibernate. It is still open source, of course, but JBoss put a lot of resources into Hibernate. I must say that Hibernate's not easy to work with. Hibernate is trying to solve a hard problem, and that's why we've got 33 chapters on this course. Now, don't worry, you don't need to do them all at once to start working with Hibernate, but I've tried to include as much detail as I can that will help you on real projects when you start to hit problems. Let's have a rundown of the chapters on the course. In Chapter 2, we'll get your development environment up and running. There's also an introduction to SQL. In Chapter 3, we'll see how Hibernate can help you persist your objects. In Chapter 4, there is a bit of configuration to do to make Hibernate run for the first time, so we'll do that there. In Chapter 5, we'll see how you can delete and update objects in the database. In Chapter 6, we'll see some of the advanced mapping features that Hibernate offers you. In 7, we'll understand how to handle crashes and how to configure logging. In Chapter 8, we'll look at how to manage relationships between objects. And in Chapter 9, we'll see how to handle collections in Hibernate. In Chapter 10, a big topic is bidirectional relationships. That's another one of those mismatches between Java and relational. In Chapter 11, we'll see how to map many-to-many relationships, and we'll do quite a lot of coding in that chapter. In Chapter 12, we'll understand how you can write equals and hash code correctly. It's essential to do this when you're working with a database. In Chapter 13, a boring chapter, when we look at how you can configure Hibernate using XML instead of annotations. This is a bit of a legacy concept, but some projects still do it. In Chapter 14, I'll introduce the Java Persistence API, or JPA. It's very closely related to Hibernate. I'll explain the differences. From here on, we start to get a little more advanced. In 15, we'll look at cascading. In Chapter 16, we'll look at embedding objects. That's what to do when your classes aren't the same as your tables. One of the most important things a database offers is the ability to query. Now, we don't want to lose that ability. In Chapters 17, 18, and 19, we explore the power of Hibernate queries. And then in Chapters 20 and 21, I'll show you an alternative way of doing your queries. We'll look at the Criteria API. And in Chapter 22, we'll look at how to handle inheritance. The rest of the chapters explore how Hibernate works in a real project's architecture. In 23, we look at detaching and merging, which is how you handle multiple tiers in an application. We then look at optimistic locking, followed by a chapter on pessimistic locking. One of the biggest things that people are interested in when working with Hibernate is, does it perform? Well, in 26, we look at performance and an optimization that Hibernate carries out called lazy initialization. In 27, we look at how to tune the performance a little more. In 28, we look at the first level cache. This is a really important thing that Hibernate's doing under the hood, but you need to understand it. Some projects will want to use a second level cache, so we look at that in 29. That's completely optional. The final 3 chapters are all about how Hibernate works in full running applications. Now, I don't know what type of application you're building, so in Chapter 30, I'll look at regular web applications. In Chapter 31, I will look at Spring applications. And in Chapter 32, we'll look at EJB applications. And there's a lot of detail in those chapters about how to make Hibernate work in the real world. So it is a big course, but remember, you don't have to do it all. The first 10 chapters are enough to get you started as a practicing Hibernate developer, and then you can pick up the rest of the chapters as and when you need them. So it's going to be a big course. Rejoin me in the next chapter when we'll set up our development environment. We will install Hibernate for the first time, and optionally, we'll have a look at the basics of SQL. So rejoin me for that.